Welcome back, students. In the previous video, we were discussing about binding energy and binding energy per nucleon. Just I want to remind, binding energy means the amount of energy required to separate the nucleons from the nucleus, or the energy with which nucleons hold together inside the nucleus, that we are calling binding energy. And what is binding energy per nucleon? The binding energy divided by mass number, or the energy required to separate a nucleon to an infinite distance from the nucleus, that we are calling binding energy per nucleon. Now today we will see binding energy curve. Binding energy curve. Look at me. The graph between binding energy per nucleon versus mass number for various nuclei, that we are calling binding energy curve. I mean, the graph between specific binding energy and mass number for various nuclei, that we are calling binding energy. The binding energy shows the stability of the nucleus. I mean, more the binding energy, more the stability of the nucleus, and lesser the binding energy, lesser the stability of the nucleus. So, the binding energy for various nuclei are shown in the graph here. First of all, what is the significance of this graph? This graph shows that whether the nuclei is stable or unstable. Now, let us see what are the features of binding energy curve. Features of binding energy curve. Let us see one by one. Features of binding energy. Features of binding energy. Features of binding energy curve. Let us see one by one. The first significance is, first of all, we should know about the light nuclei and heavy nuclei. The element whose mass number is less than 30, then we are calling light nuclei, and the elements whose mass number greater than 170, those are called as heavy nuclei. Let us see first significance. The graph shows that the binding energy per nucleon for a light nuclei and a heavy nuclei is very small. What it is? The binding energy per nucleon. Binding energy per nucleon for light nuclei. For light nuclei and heavy nuclei is very small. Is very small. I mean, the nuclei whose mass number less than 30, those are called light nuclei, and the mass number greater than 170, those are called as heavy nuclei. For both the light nuclei and heavy nuclei, binding energy per nucleon is very small. This is first feature. Then what about the second feature of binding energy curve? See here. The binding energy curve for the mass number 3 to 20. Mass number 3 to 20. The binding energy per nuclei is rapidly increases. What it is? The mass number greater than 20 to 20, the binding energy curve rapidly increases. The curve contains the peaks. The curve contains the peaks corresponding to helium, beryllium, carbon and oxygen. They show that these elements are more stable than the neighboring nuclei like lithium, boron and nitrogen. What it is? The binding energy for the mass number up to 20 rapidly increases, and the curve contains the peaks. Curve contains the peaks corresponding to helium, beryllium, carbon and oxygen. They are more stable than their neighboring nuclei like lithium, boron and nitrogen. This is second feature. And third feature is the binding energy for the mass number 30 to 170. Almost the graph is flat. What it is? The graph is flat for the mass number 30 to 170. Almost the binding energy curve is constant. the elements whose mass number is lies in between 30 to 170, the binding energy is constant, and it shows that these elements are more stable. Among all these elements, iron has the mass number 56 and it has a binding energy 8.75 megaelectron volt. Out of all these elements whose mass number lying from 30 to 170, iron has more binding energy, hence iron is a more stable element. This is third feature. Then fourth one. After the mass number greater than 170, gradually the binding energy curve is decreases. Binding energy per nucleon is decreases. This shows that if binding energy per nucleon decreases, those nuclei are said to be unstable and they act as a radioactive elements. What it is? The elements whose mass number greater than 170, for those binding energy per nucleon is very smaller and they becomes unstable. That's why the mass number greater than 170, those elements are unstable and hence they act as a radioactive element. This curve shows that for light nuclei and heavy nuclei, binding energy is very smaller, and also for the heavy nuclei, binding energy is very smaller. It indicates the both the light nuclei and the heavy nuclei, those binding energy is smaller due to they are unstable in nature. But the mass number lying from 30 to 170, almost the binding energy is constant, and these elements are stable in nature. These are what? Features of binding energy curve. Then what is significance of this curve? Significance of binding energy curve. Significance of binding energy curve. Significance of binding energy curve. Students, significance of this curve is, this curve indicates whether the nuclei is stable or unstable. Directly, this curve indicates the stability of the nucleus. This is first significance. And we say that the elements whose mass number less than 30, those are called as light nuclei. And for those, binding energy is very small. This idea used in case of nuclear fusion reaction. The light nuclei are responsible for nuclear fusion reaction, and the heavy nuclei in mass number greater than 170. This idea used for nuclear fusion reaction. We'll study in the coming videos what is nuclear fusion reaction and what is nuclear fusion reaction. Directly, the significance is this curve shows that the stability of the nucleus, and the light nuclei, this idea used for nuclear fusion reaction, and heavy nuclei used for nuclear fusion reaction. But students, inside the nucleus, two components are there. One is the proton and second one is the neutron. The protons and neutrons, they are held together by very strong force. That force we are calling nuclear force. So now let us see about nuclear force. Nuclear force. Nuclear force. Nuclear force. Look at it. Inside the nucleus, the electrostatic force and gravitational force not hold the nucleons together, because the electrostatic force and gravitational force, these are weakest forces. To overcome the stability of the nuclei, for the stability of the nuclei, the Japan physicist Yukawa, he introduced a new force. That force we are calling nuclear force. Then, how this nuclear force can be adjusted? Look at the students. First of all, I can take the atom. This is the atom. So, inside the atom, this is the nucleus. This will be the nucleus. Inside the nucleus, the protons are available and the neutrons are available. What is nuclear force here? The protons and neutrons hold together inside the nucleus by very strongest force. That force we are calling nuclear force. See here, the nuclear force, how it is arises. Yukawa proposed that. Yukawa introduced this new type of force which indicates the protons and neutrons hold together inside the nucleus. How the nuclear force can be arises here? Actually, in the nucleus, proton does not remain the proton and neutron does not remain the neutron. Instead, the proton and neutron always are interconverted. I mean, the proton is converted into neutron and neutron is converted into proton. During conversion of proton into neutron, they exchange some particle. That particle we are calling 5 mesons. How it is? Inside the nucleus, the proton is converted into neutron and neutron is converted into proton. During interconversion, they exchange some subparticle. That particle we are calling 5 mesons. That particle we are calling 5 mesons. Due to exchange of 5 mesons, the nuclear force will be arises inside the nucleus. That force holds the nucleus inside the nucleus very tightly. And the exchange of 5 mesons, it is very complicated. Simply you can say that during conversion of proton to neutron, the exchange some particle, that particle we are calling 5 mesons. Due to exchange of 5 mesons, the nuclear force between the protons, between neutron, and between proton and neutron, this will be arises. Then, what are the characteristic property of nuclear force? Let us see one by one characteristic property of the nuclear force. Characteristics of nuclear force. Characteristics of nuclear force. Characteristics of nuclear force. Characteristics of nuclear force. First of all, students, what we said, the nuclear force, this will be arises inside the nucleus. How it arises? Due to exchange of electrons. But remember this point. This nuclear force may be repulsive or may be attractive. When it will be repulsive, when it will attractive, we will explain it later. Look at here. So, during exchange of electrons, the nuclear force can be arises. Let us see one by one characteristic property. The first characteristic property of nuclear force. The nuclear force is the strongest force in the nature. Nuclear force is the strongest force in the nature. It is strongest force in nature. Strongest force. See here. Actually, inside the nucleus, three types of force are available. One is nuclear force, second one is gravitational force, and third one is electrostatic force. Because inside the nucleus, two masses are there. Proton, neutron. Proton, neutron have the masses. Due to masses, they can attract. So, gravitational force must be exist. And inside the nucleus, protons are there. In between proton and proton, in between two charges, there is a force available. That force we are calling electrostatic force. Along with, due to interconversion of proton into neutron and neutron into proton, the exchange of particles that we are calling 5 mesons. Due to exchange of 5 mesons, a nuclear force can be arises. Experimentally shown that the nuclear force between two protons, it is greater than 100 times of electrostatic force. How much it is greater? As compared to electrostatic force, nuclear force is 100 times greater than electrostatic force. And as compared to gravitational force, nuclear force is of the order 10 raised to 38 times or greater than gravitational force. How it is? The nuclear force between two protons, how much it is greater? It is greater of the order 100 times of gravitational force. And as compared to, in between two protons, how much it is greater? As compared to electrostatic force, this nuclear force is of the order 100 times greater than electrostatic force. But as compared to gravitational force, this nuclear force between two protons, it is of the order 10 raised to 38 times or greater than gravitational force. So, this nuclear force, it is of this force in nature. And second properties, the nuclear force, it is a charge independent force. How it is? Nuclear force, it is a charge independent. It is a charge independent. It is a charge independent. Charge independent means we can found that inside the nucleus. The force actually in the nucleus, what components are there? Protons and neutrons. How did that exist? Nuclear force can be exist in between two protons, or in between two neutrons, or between protons and neutrons. Right? Experiment is found that the nuclear force between two protons, nuclear force between two neutrons, and nuclear force between protons and neutrons approximately same. How it is? In between proton and proton, or in between neutrons and neutron, in between proton and neutron, almost this nuclear force, it must be same. It shows that the nuclear force independent on the charges. It must be independent on charges. Then, third property can say. Third property can say that the nuclear force, it is a spin dependent force. Nuclear force is a spin dependent force. It is spin dependent force. Spin dependent. Spin dependent mean what? Spin dependent mean the nuclear force between parallel nucleons is more as compared to nuclear force between anti-parallel nucleons. I mean, if the nucleons having parallel spin, for these nuclear force is very stronger as compared to the nucleons having anti-parallel spin. I mean, for the parallel spin of nucleons, nuclear force is more as compared to anti-parallel nucleons. That's what nuclear force is a spin dependent force. Third property is. Then fourth property can say that. The fourth property can say the nuclear force is a saturated force. Nuclear force is a saturated force. It is a saturated force. It is a saturated force. Saturated means what? The nuclear force can be adjusted only to nearest neighbor. For example, I will take different type of nucleons here. See here, these two nucleons, and this is one nucleon. The nuclear force can be adjusted only to nearest neighboring nucleon, but not to this nucleon. I mean, the nuclear force can be restricted only to nearest neighbor, not for the far nucleon. That's why the nuclear force is a saturated. Saturated means the nuclear force can be reduced only to nearest neighbor, not for the far nucleons. saturated force. And fourth one you can say. Fourth you can say nuclear force is a non-central force. How it is? It is a non-central force. It is a non-central force. Nuclear force is a non-central force. Non-central means what? The nuclear force is not acting along the line joining from proton to proton, or from neutron to neutron, or from proton to neutron. It is not acting along the line joining between the nucleons. This indicates the nucleons are not uniformly distributed inside the nucleus. The nucleons are not spherically symmetrical distribution inside the nucleus. How it is? Non-central nucleus what? This force not acting along the line joining from proton to proton, or from neutron to proton, or from neutron to neutron. This indicates what? The nucleons inside the nucleus are not spherically distribution. The next property can say. Next property can say nuclear force. It is short range force. Nuclear force is a short range force. Nuclear force. Nuclear force is a short range force. Short range force. Short range one. Students, first of all, we know the size of the nucleus. The size of the nucleus lying of the order 10 to minus 15 meter. Inside this nucleus only this force must be exist. I mean, the nuclear force must be valid if the distance between two nucleon is less than 10 to minus 15 meter. This force must be valid by the distance 10 to minus 15 meter. In the case, the distance is more than 10 to minus 15 meter. And if the distance is lying of the order 10 to minus 14 meter, 10 to minus 14 meter, practically for this distance, this nuclear force must be zero. I mean, beyond this distance or exactly at this distance, nuclear force must be zero. That's what this nuclear force is a short range force. We said that, students. At the distance between two nucleon decreases, nuclear force must be increased. How it is increased? Already we said that nuclear force may be attractive, nuclear force may be repulsive. This repulsive force prevents the collapse of the nucleus, and attractive force holds the nucleons inside the nucleus very tightly. Then when repulsive force must be exist, when attractive force must be exist. In the case, distance between the two nucleon is less than 0.5 into 10 to minus 15 meter, repulsive force is arises. And if the distance is more than 0.5 into 10 to minus 15 meter, then attractive force is arises. Then as the distance changes, nuclear force must be arises. Graphically and experimentally, how to show? Experimentally, the nuclear force changes as a function of distance. How to show? What we said? Nuclear force may be repulsive, it may be attractive. See here, how it will change. See here, I will take this the distance and this will be the force along y-axis. Right. So, nuclear force must be changes like this. Must be changes like this. In this case, repulsive force must be increased. And in this case, attractive force must be arises. Attractive force must be arises. Shall I draw distance here? Distance I will take 0.5. This is what of the order 10 raised to minus 15 meter I will take. 10 raised to minus 15 meter. Distance is of the order 10 raised to minus 15 meter. So this is 0.5 into 10 raised to minus 15 meter. This is what 1 into 10 raised to minus 15 meter. This is what 2 into 10 raised to minus 15 meter. How much it is? So you can take this value as 3 into 10 raised to minus 15 meter. What we said? If the distance is less than 10 raised to minus 15 meter, 0.5 into 10 raised to minus 15 meter, repulsive force is arises. And if the distance is greater than 0.5 into 10 raised to minus 15 meter, attractive force is arises. So, at a particular distance, nuclear force is strongest force. If the distance between two nuclei of the order 0.75 into 10 raised to minus 15 meter, at internucleon distance, that is of the value 0.75 into 10 raised to minus 15 meter, nuclear force is maximum. Again, after this distance, gradually nuclear force is decreases as a function of distance. That's why nuclear force is a short time force. So, what are the properties of the nuclear force? Nuclear force is the strongest force in the nature. Nuclear force is a charge independent force. Nuclear force is spin dependent force. And nuclear force is a saturated. And nuclear force is non-central. Along with the nuclear force must be the short time force. So these are what field properties of nuclear force. So remaining things.